3, 2. Great. Okay, welcome to Tech at Scale Toronto. Obviously, the event is brought to you by 500 Pixels. One of them is right there in the shirt. Thank them, you know. And then I work at Blue Cat. Some of us are from Blue Cat. Some of the food's from that. Rest of the food's from you. Thank you. Oh, we're both the co-organizers, by the way. So, oh yeah, if you have venue space and would like to give it to us, not that we have any problem with 500 pixels, right? We just don't want to always show up here, you know, or you want to volunteer, you have something that you want to talk about. I'm doing a podcast, 2 podcasts this year. You want to be on podcasts, there's my email. Find me afterwards or find you afterwards and we'll make it happen. So yeah, really another meetup. Really, and we're getting to the talk. This is just like the intro, first one, you know. I didn't want to have a meetup that's like all salesy and marketing, and the company just basically comes and tries to do only like recruitment. And that's actually kind of how we met at another meetup. Was they didn't care really about the tech. They're like, recruitment told us we had to do this technical talk. And the trend is more and more companies are getting into big data. There's just more data. And it's technical focus. So if you're coming here and you're like, hey, I have 0 coding at all, I mean, unless you find this just interesting, then cool, but they're going to be pretty technical. It's not a like, you know, hey, I'm going to tell you that data scientists make 100K and you should become one, right? Yeah, I work at Blue Cat, but everything I say here is not Blue Cat's opinion, and nor should you think it is. Disclaimer, so you know where I work doesn't get pissed. Okay, so the real talk. Rest in peace, Apache Kafka, long live Apache Pulsar. And I figured probably half of you were triggered when you saw the meetup and you're like, pizza, drinks, and this guy's probably wrong. So let's see. So yeah, my name's Cory, one of the people who organized this. The last company I worked at, we did the analytics project. It took 3 billion incoming events. And presently at Blue Cat, we're building out this 200 plus PB data lake. And FYI, most of the slides you've seen is powered by PowerPoint design ideas. So the AI has chosen most of this. So if you think there's bad choices, blame the ML and AI and not me. As you can see, there's no transition. I forgot to add it. So let's start with, just leave your hand up. Who knows about Kafka? Okay. Who's worked with Kafka as a consumer producer? Okay. Who's managed Kafka before? So there's your ops people. Wow, very few ops people. Okay. And is there anyone seriously using Kafka, like 100 terabytes or 10 brokers? Okay. Just context for me. And who knows about Pulsar, aside from knowing this meetup title? Okay. And is anyone actually using Pulsar? Okay, so 2 people. Okay, cool. So it's like, it's fine if you're not in this. I'll try and skim over things that are really intro, but basically you don't need to know everything about Kafka, just what Kafka is, even if you just like, I know it does things with logs. Great, that's a great spot. Know why it exists, and if you have any ops exposure, a lot of this you're going to really get. You're gonna be like, wow, this person lives my life. But if you don't, I'll walk you through it anyways. So. And if you do use Kafka, a lot of the things you'll see in here, you're going to go, but Kafka does this, Cory. Kafka does this, Kafka does this. I know. I've written some of this, like Apache Flink jobs that do this or Samza jobs that do it on behalf of Kafka. The difference is a lot of what I'm going to talk about is first-class citizens, aka you don't do anything, and Pulsar provides it to you, versus with Kafka, it's like, yes, it does that, but I had to write a custom script for this, or I had to do custom partitioning for this, or I had to do it downstream, or etc. You get the point. So what are we basically comparing? This is like for the people who aren't really familiar with this. It's basically Kafka is this distributed streaming platform that deals with what you can consider streams. Most people are using it to push in some sort of log, if you want to call that, or event. And Pulsar is going to basically be doing the same thing, but yeah, there's some differences, and it's pub/sub messaging platform instead, but I'll cover through this. So why does these tools even exist in the first place? Basically, they're there to solve streams, and we have bounded and unbounded streams, basically streams that we don't know when they end, or streams that are fixed. Fixed streams you're used to would be called like your batch processing in batches, because you know it starts here and it ends there. Your unbounded is, I don't know when it ends, right? It just could continue on forever. That would be your real-time kind of stuff, right? Or you're not picking a fixed spot. I want every Uber drive since the beginning of time to continue. They're happening right now, right? That's our unbounded kind of stuff. So everyone always talks about this. It's created Yahoo. It was closed source. Then they open sourced it and donated to the Apache Foundation in 2016. I'm sorry that the slide font's not bigger. I thought it was going to be on a projector screen, but I'm recording it. I'll put it on YouTube. There you go. And Yahoo ran it in 5 years of production. So it's battle tested. How battle tested? Well, Yahoo's actually a pretty big company. 2.3 million topics. They deal with 500 billion messages a day. Basically, there's a few other companies. There's maybe Netflix, Microsoft, Apple, Facebook. That's going to really trump this kind of stuff, right? So Pulsar in a nutshell, from the outside world, if you're familiar with these, great. It's basically like you took everything great about Elasticsearch in terms of cluster management and RabbitMQ and Kafka, and you're like, here's Pulsar. Because it looks like cluster autopilot. The cluster is just doing everything for you. And you get message queue, and you still have streams, and you end up with Pulsar. Looks like this. So you have producer. It obviously produces messages for anyone not familiar with this kind of world. Your consumer, it's reading in these messages. Oh, I missed a slide. So one of the big differences that we start to see is if you're from the Kafka world, you don't have this bookie layer on the bottom. That doesn't exist. You just have brokers. So there's a split architecture here. So Pulsar takes this multilayer architecture. They split serving from the storage layer. So from the Kafka world, which looks like this on the left side, serving and storage is coupled on your broker. There's no separation. Your broker runs both. That's it, right? Versus on Pulsar, it's entirely different. You can have a broker you can run it on the same if you would like to do that. But you can run the broker as a standalone thing and the storage layer as its own standalone thing. So some of the reasons why we care is the writes start kind of changing. We can do Streamtail reads. What that means is if I just wrote something, ideally the broker would serve this back without going to the disk. It might be in the memory, it might not be in the memory, but if we have this option in the broker layer, we can take advantage of it. And altogether, so left is Kafka, Pulsar is the right. We'll get further into this, don't worry. It will make more sense. Essentially, it's one is coupled, and one took 5 years before Yahoo sat there, waited 5 years, and said, what's everything that we don't like about Kafka? Well, I don't really like that the storage and the serving layer are coupled, and I only can deploy them together. So Pulsar came out and was like, hey, there's the Apache Bookkeeper. We could do this, and now they're entirely separate concerns. And obviously, there's great advantages here because Apache Bookkeeper is a different project. It's evolving on its own. Its only concern is storage, storing the logs. That's it, right? Versus in Kafka, all of a sudden now you take all this responsibility and ownership of also dealing with all that, right? So let's talk a little bit about this broker layer. So one of the big things that you will come to realize if you're not familiar with Kafka is Kafka brokers are not stateless. So in Pulsar, they are stateless. And we will care greatly about this as I continue in the scenarios. But basically, most of you as devs know that, like, hey, if we can make something stateless, it's better because we can just tear it down and replace and not have to worry about anything, right? Well, Kafka doesn't do this. The broker has state with it because the data is there. So Let's talk a little bit of storage. So Pulsar, way different. So if you're familiar with Elasticsearch, this will seem very similar to kind of Elasticsearch world, right? It does this thing where it can do segmented logs. So in Kafka, you basically get just your partitions, right? That's how you segment your streams, is in partitions. That's it. Pulsar goes one step further and says, well, I can break up the partition into segments and have those segments live in different spots. This is kind of similar to Elasticsearch if you're familiar with shards and things like this, right? Why we care about is, well, there's a lot of ops things that we can do with this. There's a lot of performance stuff. It's in the next slide, so we're going to talk about. But it's a way different approach, right? Well, one of the first things you can see is, well, smaller chunks is usually better, right? If I have a partition that's 100 gigs and anything happens in there, all that partition is just bye-bye. There's no recovery. It's basically, okay, assume the partition's just corrupt, start from start, replicate the whole partition over. Well, in this case, if I have 10 segments over the 100 gigs, right, 10 gigs, okay, I only have to replace that 10 gig segment. Like I said, if you're familiar with Elasticsearch, you're used to this with shards. So side by side, obviously there's big differences, right? Partition 1 is this huge, massive thing versus we still have partitions, but they're broken up into segments, and those segments can go across different boxes. So right there, we immediately start realizing that, oh, wow, so my partition is actually across many different boxes, or can be, n boxes. Well, obviously, this is going to help with things like performance. As I had mentioned, Pulsar leverages Apache Bookkeeper. We like this because it's not our concern. Storage optimization, like I put this diagram not so you read it. I put the diagram so you realize how many things there are with storage. Like, do we buffer? Do we cache? Was the write really a write, or is it in a buffer write? Like, how do I do tail reads? Is it in the journal file? Is it not in the journal file? How should I write it in such a way? There's a lot of things under the hood. In Kafka's got to deal with all this because they've taken it up on themselves, right? Pulsar goes, great, Apache Bookkeeper is evolving. They're doing all this for me, and I'm just treating that as a storage layer. So it's our black box, right? So it sounds just like fancy stuff. Cory, you're just talking about fancy stuff. I'm a diehard Kafka fan. I think you're full of shit. Well, it's better latency on Pulsar. And it's substantial way better throughput. And it's because of things that we can do where we separate our concerns. One, this allows us to take advantage of things like something as simple as our storage boxes, we probably want to pick the most optimized box for storage. I would like to pick the NVMe SSDs on AWS, the i3 type boxes, versus like the general compute boxes. But in Kafka world, you're trading off because now you're reducing the throughput because everything's going through your broker before it gets to storage. It's coupled in Kafka. So on Pulsar, I can have really good the C-type CPU boxes as my broker layer, and then I can run i3, which is the NVMe SSD boxes behind that as the storage layer. So there's nicer things. So one of the nice things that Pulsar exposes that you can't even do this in Kafka, or I have no way, or maybe there's a KIP, or maybe you're writing this, but you can actually access the data without going through the broker at all. So, and I know if you can actually see the diagram up here, you will see this arrow, and you're like, Cory, that's a lie. I see a line to the broker. That gets the metadata. So it asks the broker for the metadata of how it was stored on Apache Bookkeeper, but it's only asking for the metadata. It's not actually asking for the data to go through the broker. We can actually pull all the data out directly from Apache Bookkeeper. Why do we care? Well, if I'm asking for, give me everything of 1 petabyte of data, all that has to saturate my egress on my brokers. It's all data that would have to go through my brokers. And you have real-time streaming apps, real-time streaming applications, so you don't want to impact any of that, right? Like, I don't want to say, well, I want to run a batch job on the data, and I need 1 petabyte, and now you affect the real-time stream. Because in Kafka, everything's going through a broker. Your batch would go through your broker, your real time's going through your broker, it's all coupled. You don't get access directly to the storage. To get access to storage, you have to go through the broker, period. Now, correct me if you're wrong of a new KIP. I don't use 2.6 Kafka that I think it is up to. I'm more on the Kafka 1.x days, so recap, rest in peace Kafka. Why? Because some of this is just the start of many things, but so we get tail reads. What that means is if the broker has just written something, we can ask the broker immediately to give us the data. Don't even go to the storage layer. You actually have it. You just wrote it, right? So we get better latency and throughput based off of decoupling our concerns, and we can get data without even going through the broker. We just ask the broker for the metadata. Hey, how did you write it on Apache Bookkeeper? Great. Go to Apache Bookkeeper and now say, I want this data. And now I don't have to go through the broker at all. So let's talk about some of the real problems, not just like, hey, it's faster. So broker expand. For the people who are in ops world, this is probably going to be your nightmare. The next couple slides. People who are not, this is why your ops people don't like you when you use Kafka. Or they're like, you need to write tooling, a lot of tooling. Because usually what I hear is, Netflix does it. Yes, Netflix has over 1,000 Kafka clusters. They've literally built it so everything is infrastructure as code. And today they click a button and they tear down the entire Kafka cluster and it spins up somewhere else. If you're in that scenario, then great, Kafka is wonderful. I'm not, probably most of us aren't, right? So when you have something like a broker die in the middle of the night and you get a page, yeah, brokers aren't stateless. And so you're like, well, don't I just add a new box? No, my friend. You must add a box that matches the same broker ID if you want to replace that box. So if the broker ID on Kafka broker 1 is 1, then obviously when you spin up a replacement box, you set the broker ID as 1 so that it knows to go to the following nodes and ask to replicate all the data and all this. It doesn't auto-join. This is not like Elasticsearch where you're just like, nodes, it's not my problem. I don't care. The cluster is self-aware. The cluster manages itself. Doesn't exist. So you're like, Cory, doesn't sound like a big problem. Does when it's 3 a.m. Infrastructure as code. You could write the tools around this. Few people do it well. I haven't seen many places do it. Even the last place I was at, it didn't happen that often that we even spent the time writing infrastructure as code. We had an ops guy literally go in, look at the inventory. Oh, IP or box blah 123 died. That was Kafka broker ID 5. Okay, we need to spin up a new box and set the config as Kafka broker ID 5. And yes, there's tooling for this. But it would be really great if we didn't have to do any tooling, right? Because Pulsar doesn't care. You just add nodes. You add brokers, and it does the rest for you. Like, there is an asterisk. There's technically an internal state to the broker. It is basically a lock, but you can tear it down and the cluster will solve this for you. It basically says that the broker 2 is only allowed to touch partition blah in these segments. Why I say it's stateless is because you can actually just delete it and you don't care, because when you add a new node, the cluster will go, actually no one owns partition blah in segment ABC, so I will give that ownership. In Kafka, I can't do that. In Kafka, I take down a broker and I add a new box that has Kafka. It's going to do nothing. It's like, yo, bro, what's my broker ID? I don't know. Like, these are real ops pains, and like this is why like ops teams don't really like. I mean, you like it because it does a lot, but okay. So next problem. Okay, Kafka storage problem. Let's say you have a write problem, right? These aren't crazy. I have a hotspot, which means there's a lot of writes going on to topic 1, partition 1. It's writes. I can't just solve this by adding more boxes because of reads. You could do that. You could just add more boxes, just more ISRs, like follower nodes. Great. But if it's write, I can only write to the leader. What do? We just like scale up the box bigger? Well, you got to remember, distributed system, if it is, you scale up one box, you got to scale them all up. Like, especially in the cloud world we live, because that one box could die and everything could transfer over somewhere. And if this box was running these ultra-fast SSDs and the other box isn't, you just move the problem, right? And it's a temp fix, yeah, it maybe gets you through the night, but now all of a sudden you have to revisit the problem. So hotspots, not really solvable. In a Kafka world, people just go, why don't we just add more partition so the hotspot's smaller and we have less chance of this? Yeah, but you can't dynamically repartition. So you can add more partitions, but then you are going to probably break a contract with your dev, or you add more partitions and then you're going to do the famous rebalance, which is super intensive on your cluster. But the worst thing with your rebalancement of anytime you do a rebalancement is you break the golden contract with your dev, which is the order in which you've read the messages in your partition will always be the same. Not if I rebalance, because some of those records have moved. So now every dev who's written anything that uses it better take this into case. Oh, better take it into better take it into case. Yeah, better take it into consideration there. Read problems. So you have a hotspot on read. Like, I just want to add another node. Same problem. I add another node. Now I need to go in configuration, or it needs to be infrastructure as code. Like, it's all doable. It's all tooling that you just have to write. It's not out of the box. Or maybe you find a GitHub project that works and still maintain. I mean, half the time you find a Netflix project, you're like, it's solved. And then you're like, wait, this is like 6 repos ago, and they actually don't maintain this anymore. But they haven't released the closed source version they're using internally. So Pulsar doesn't care. It just doesn't care. Just add more nodes, bro. You just add more nodes. And it's going, so you add new bookies, which is the storage layer. And the cluster, by default, no tooling, no magic, automatically tries to prevent thundering herd. So it knows that when you add the new node, I don't want to just move a shitload of segments over. Because what happens is those are all your hotspot segments. Because now I've just moved the problem, right? So it's going to add just new segments to that and slowly move over segments behind the scenes. Elasticsearch, you're familiar with Elasticsearch? This is usually what Elasticsearch is doing behind the scenes. Oh, you added a bunch of new nodes, I should move off segments that have high reads or high writes over the nodes that don't have anything, right? So, and the beauty is, let's say that our throughput's not the issue. Our brokers are totally fine. Low CPU, great. We just have storage issue. Great, just add more bookkeys. In Kafka, you don't get this choice. You immediately, by adding more storage, you added another broker. Yeah, send the police. That's how bad it is. So I don't know if it's my talk so bad that the police are coming, or like, oh, okay. Oh, we're on fire. I'm on fire. Ah. So storage failures, right? Partition 1 dies, or there's an issue. Well, means we just lost that broker too. So the disk dies, the broker, you can't use the broker anymore, right? Some component of my partition dies. Disk seg faults, bad segmentation on the disk, something like this. Anything happens to partition 1, the whole partition is considered not good. So you just lost the broker too. And you lost the entire partition. Well, the beauty is, Pulsar, when you have segments, you just lose that segment, right? Another nice fact is when you're recovering, so you're moving your segment somewhere else to replace the dead segment, and you're not doing this, actually. Pulsar's doing this. It's not run tool X. Pulsar's doing this, right? So when Pulsar says, hey, segment 4 died, or I can't read segment 4, or I want to move this, it can move it somewhere else to a different bookie, but it can read from multiple different segments, right? So, hey, bookie 3 and 4 both have segment 4. So I can async read from both of them. I'm going to start one from the head, one from the tail. 2x our read. And n, because there could be more than just 2 nodes. So write instance type for a given demand. I want to scale out brokers. Great. What type do you want? It's just going to be memory and CPU. So just pick the best instance type for that. It doesn't even actually need any NVMe SSD at all. Like, I come from a mostly AWS world, right? But physical boxes, even worse, because now you have inventory, right? So if you have to physically buy this, this is the worst case, because now you're like, I I have to buy the box that's in the middle for Kafka, which is its decent disk and decent CPU. With Pulsar, you're just like, it's a broker? Fuck. No SSD, no spin drive, just the boot. Like, that's it. We just care about the biggest CPU we can possibly put there. Same thing for the bookie, right? I don't need this crazy, 32-core CPU box, but yeah, I want that PCI Express SSD. Like, so TLDR, too long, didn't read. Basically, the point is that you try and scale with Kafka, and it's like, yeah, well, you have to rebalance that. Good luck. Pulsar, you just add the nodes. It's not your problem. It shouldn't be your problem either. And this is why, like I said, the ops people will feel my pain because, I think it's actually one of the reasons why Elasticsearch became so popular is you don't deal with this. It's the clusters problem. It's the clusters management. You're just like, I'm just going to add it when there's an issue. You move everything. You figure it out. Don't want to deal with it. So basically, Yahoo is very smart. Sat back, let Kafka make all these mistakes, and then go, if we could rewrite that today, what would we do? So recap for this: seamless broker expand, seamless storage expand, seamless failover, independent expanding, serving, or storage. So now let's talk about not so much where Kafka fails, but more like some of this just doesn't exist. So without you writing it yourself. So usually for me, a lot of what I'm about to talk about, I would write in Flink or Samza and handle it over on the framework that I'm using. Exclusive, I only want one consumer to ever be able to read this from, I want one job to read from this topic and only that job. So only one consumer, that's it, right? You can write this in your framework. You just have it so that it has a lock at the start of the code when it initializes. Make sure no other job is running. Maybe you're using Redis for the lock, etc. We can write this. I would rather just Pulsar be aware and say, hey, this subscription group has one consumer. Another consumer tries to join. No, too bad, you can't read, denied. I'm just going to kill your connection. I don't want to write the code. Failover. Well, I would like to have a consumer and another consumer on standby. And if consumer A dies, consumer B can take the message. Great. Could also write this in your framework. Shared is the most common one that we're used to, which is you just have many sharing a topic, usually mapped to your partitions. And key share, don't even worry about key share. It's such a unique case. It's only if you're doing like custom mapping to the partition or you're sharding something based off the partition. It's the same thing as shared. You just, your consumer is only going to get a certain key value, and that's it. So, like, exclusive and failover, pretty common. I want a job in Apache Flink where there's only one job because it needs to do the final aggregation. So something like billing. Eventually, you're going to hit a spot where only one thing can do the aggregation, right? Like the total, right? You can do many async, aggregation, etc. But at some point, you're going to go down to one spot, right? And exclusive's nice because you have this transactional contract. It's just me. There's no one else. I don't have to worry about anyone else doing anything. Something that goes over your billing. I want one job to only run and count out blah, or make sure that this transaction happened. I don't want 10 jobs because then I have to implement all this locking and things like this, etc. So, and plus, if you had many jobs, you would run shared, where many consumers can read from the same topic, right? So, doesn't exist in Kafka at all. This is not a Kafka thing. This is every time I face this problem, I've written it in the framework. So, and I don't want to because it's the same extend blah class that I basically have to write in company A and then write the same thing in company B. So. Message retention. Now, anyone who's used Kafka goes, bullshit. Kafka has retention. Yes. Asterisks. It has two types of retention. It has a window retention and a size retention. Or the last that I used it had these. This retention is things like, if I don't, if all of my consumers acknowledge this, delete the message. If I have 10 consumers in a subscription group and everyone acknowledges the message, please delete it. Well, that would be great because I don't want to actually hold the message. Most companies, what they do is they set 72-hour window on Kafka. Why? Because if there's an issue on Friday, the dev doesn't want to deal with it on the weekend until Monday, and they don't want the message deleted from Kafka. So they set the retention window to 72 hours, which means for 72 hours, you're holding on to everything. So if every day you generate 1 PB or 100 terabytes of data, it means that you're holding on to 300 terabytes when you don't really need to. The ideal world is hold on to the data in the shortest amount of time until everyone acknowledges they've read it, and then drop it. Like, most of our cases will fall underneath this. There's also things like message expiry. If no one reads it in 72 hours, drop it. If no one reads it in 2 hours, I don't care. So, doesn't exist. Does not exist at all. And it's nice because this pairs well with, I don't have the slide, I'll briefly talk about it at the end, tiered storage. So if no one reads the message in 24 hours, please move it to S3. Right? Please move it to my HDFS cluster. Please move it to my spin disks because I don't want it on my expensive SSDs on Amazon. Right? You could do this with Kafka. You write another job that is running and basically is keeping track of where the consumer offsets are for every other consumer you have. And this one job's only goal is to go, oh, no one's consuming blah. I'm going to move this to S3 and just wait for the retention window to eventually expire. But you still have to hold on to the data. If you want to get to really super sketchy stuff, like other companies do it where, well, I'll leave the retention window really small and I'll write all this tooling to realize if my consumers fall behind to change the configuration on all the brokers and do a rolling restart so I can dynamically go from a 3-hour retention window when there's no problem to indefinite if there's a weekend problem. Doable. One, I don't want code that does something like that because if it does mess up and instead of 72 sets like 0 and everything just goes delete, I would rather it just be a first-class citizen. Like it's 2020. So, and this is where you get more like a queuing system. If you're familiar with like RabbitMQ, the message has been acknowledged. Please drop, right? Multitenancy, that doesn't exist in Kafka at all. So Pulsar has basically, this is an older slide. They call them tenets. And then they have these namespaces and topics, so you can do separation, which is built in. And you're like, well, I don't really have a use case for this, Cory. This doesn't sound that important. Well, with multi-tenancy, you get roles and permission. I'll just read it to you, don't worry. When you create a tenant, you can say, this tenant only belongs in cluster A. This tenant only belongs in cluster B. This tenant belongs in cluster A and B. The same thing for the namespaces. You can say, well, in namespace data science or namespace analyst, they can only consume. They can't produce messages. Oh, you're an analyst? No problem. Here, just do whatever you want. They can't write any data in the space that you've just given them. This is wonderful because if anyone's dealt with Kafka long enough and gotten like a page or the cluster just dies or stops and you're like, what's going on? And then you realize, oh, wait, someone had access to prod and randomly wrote a message that doesn't conform to whatever we're deserializing, right? Or, oh, whoops, I didn't know that I can't send in a UTF-8 character and blah. I didn't know you didn't support that. Whoops. Well, I can just give people restricted access. You're an analyst, you can read anything you want. You can't produce a single message. Your POC team, well, everything you produce is only going to go to one cluster instead of all of our clusters. It's only going to go to our staging cluster instead of our prod clusters, et cetera, et cetera. Oh, as always, you can do this with Kafka. Just write all the tooling. I'm very lazy, as you find out. Also gets important with Geo Replication. first class citizen for Apache Bookkeeper. So it has rack awareness. Great. That's all dandy. I moved the slide, but so one of the things that we're going to find out with Geo Replication is basically Pulsar has 2 Zookeepers. I know most people hate Zookeeper. It's all right. I'm with you, but they're using Zookeeper. It is what it is. So you have a Zookeeper that is basically aware of the global state of each of the clusters, and they have a Zookeeper within each cluster that's aware of the cluster itself. Now, we care about this. Oh, yeah, I put these. Whoops. Because I want Geo Replication on Pulsar, not the storage layer, not that the message is written in 3 spots, that cluster A replicates everything it has to cluster B, and everything from cluster B goes to cluster A. The Holy Trinity, 2-way replication and clusters. And it doesn't have to be this way. You could say that US West only replicates to EU Central, and EU Central only replicates to US West, or vice versa, or EU Central only replicates to APAC Australia, which I didn't even know was a zone until now. But it's and 2-way. Like, this is the active, master, all the scenarios everyone dreams of, and like, so you're like, Cory, there's a Kafka mirror maker. Okay, you don't even get to talk to me if you're talking about V1 because it's so bad that Uber literally wrote uReplicator. That's how bad it is. Like, that's what you're dealing with. Like, when another company has to go and actually go, I'm going to write an open source version because it's so bad that I'm not even going to contribute to the open source. Guys, that's pretty bad. Now, they learned, they wrote V2 Kafka mirror with not as many problems, but honestly, I have not used it because I'm sold on this. I'm sold on Pulsar. It's also 3 commands. What you just saw, that entire diagram, to have the 2-way replica is 3 commands. There's no fancy tooling. There's no fancy run these 20 agents or only with this, or you'll literally, and this is like from start to finish. This is, you're creating a new tenant, you're setting admin roles, so who's allowed in, and you're saying these are the clusters allowed. Then you're saying the namespace that you want to replicate across everything, and then you're basically just setting it, and that's it. You don't do anything else. 2-way replication, done. 3 commands. I like this one slide is just like, all right, guys, shut my laptop. I'm done, because I wish you could feel my pain with Kafka Mirror Maker. Like just punch yourself in the face twice, and you feel maybe a little bit of it. So, discovery. I want to get a tenant that's only in the US, right? So as a dev, I don't want to care at all about this. I'm a dev. This is not my world. I don't care. I just want to get my data, right? Like, let's say, I don't know, you're the US government, let's say, the US government. And the US government says, listen, my data can only be in the US, right? Well, it's really good when I can say, okay, no problem. That tenant, US government, and the namespace of CIA, whatever, is only going to exist in the US cluster, and it's not going to geo-replicate anywhere else. But then as a dev, you're like, shit, man, ops tells me that I have to go to this one special cluster only for this one client. Now we need to track which clients are where, and now we need global access to this. Do I make an API call? And all of a sudden you end up in this crazy building thing. Except Pulsar has this discover stuff. So you actually can just, over DNS, call into the cluster, and you're like, hey, I'm looking for that US government tenant. The namespace is CIA. And Pulsar comes back and is like, great, you want to be there. No special magic in your consumer or producer. All abstracted from you. Not your problem, right? Ops just runs 3 commands, well, basically 3 commands, as you saw. That's it. You as a dev, you're just showing up with your client. You're just saying, my tenant is US government, my namespace is CIA. You have no awareness that there's even geo-regional clusters or anything like this. You don't even have a concept of that. So message acknowledgement, subscription types, multi-tenancy, geo-replication, proxy, discovery. There's tons of other stuff. Like tier storage we talked about, there's schema registry with Avro right in there. There's encryption. There's topic compaction, which, yes, Kafka has. Everything has a RESTful API. Yes, there's a KIP. Yes, they made the improvements on Kafka to finally start exposing this. Not all of it. Authentication providers are there. Prometheus is right there as a first-class citizen that you can just export to. Like, every time you're sitting there and you're like, for me with Kafka, it was like, man, I'm tired of writing this thing for like the third or second time for some X client that just needs it this certain way. Like, I wish it was a first-class citizen. Like, in 2020, you're telling me that Kafka doesn't have a way to move data off to a tiered storage? Like, Confluent is not a tiny company, guys. Like, unless there's a new KIP that all of a sudden does this, like, yeah. And so, yeah, once again, this slide. So, and we can open up for questions, and I can unplug and let you set up.